Welcome learners. I am Kakoli Gogoi from Geology Discipline, School of Sciences, IGNOU. Today I will be talking about sedimentary petrology. This is an introductory video regarding sedimentary petrology. So, the outline of my talk would be, I will give an overview of sedimentary petrology. Then I will speak about the importance of why we should study sedimentary rocks. Then we'll discuss about the sediments that make the sedimentary rock. Then there are kinds of sedimentary particles. And after that, I will discuss the types of sedimentary rocks. And I will give some example of common sedimentary rocks. And finally, I will discuss the processes of sedimentary formations. At the last, I will summarize my talk. So, learners, you see, petrology is a branch of geology where we discuss all the aspects of rocks. So, there are three types of rocks like igneous rock, sedimentary rock and metamorphic rock. And where we study the sedimentary rocks, they are known as sedimentary petrology. Likewise, when we study the igneous rocks, they are known as igneous petrology. And for metamorphic rocks, they are known as metamorphic petrology. So, coming to sedimentary petrology, this is the study of sedimentary rocks. All rocks, they are formed by the accumulation and solidification of sediments. And sedimentary petrology, this is concerned about the origin, the composition and the structure of sedimentary rocks, as well as the processes that create and modify them. So, this sedimentary petrology, this is very important for understanding the Earth's surface processes and the history of Earth's environment. As these sedimentary rocks, they contain a record of the conditions under which they are formed. Sedimentary petrology, this is also useful for identifying the sources of minerals and other resources. So, now let us talk about the importance of studying sedimentary rocks. Why should we study sedimentary rocks? So, you see the study and the analysis of the structure, the texture and the composition of the sediments and sedimentary rocks. This enables the sedimentologist to comprehend about the origin of the sedimentary rocks in order to deduce the environment of deposition like the ancient shorelines, the mountains, the riverine floodplains, deserts and also swamps. So, you see the sedimentary rocks, they are very valuable sources of energy like oil, gas and coal. These are the fossil fuels. And even you see the sedimentary rocks are almost, they are 75% there in the globe. And likewise, we find these valuable sources of energy, oil, gas and coal. And these fossil fuels, they are derived from the maceration of organic matter that are present in the sediments. So, after that, these fossil fuels, they migrate to the suitable reservoir, which is mostly porous sedimentary rocks. Now, sedimentary rocks, they also supply much of the world's iron. They also supply aluminium, potash, even salt, building materials and many more other essential raw materials. This comes from sedimentary rocks. And we should study sedimentary rocks because there are many reasons apart from, you see, from the wealth of economic minerals and materials contained within the sedimentary rock. So, there are many reasons why we should study sedimentary rocks. Now, let us discuss about sediments. What are sediments that ultimately forms a sedimentary rock? So, the term sediment, this is derived from Latin word like this is sedimentum, which means to settle. This settle can be a reference to solid material that is settling out of a fluid. The fluid may be water or even air. So, sediments, they are the loose solid materials. The materials can be detrital, the materials can be terrigenous or even clastic materials. These sediments, they originating from the breaking apart of older pre-existing rocks by the process of weathering and erosion. So, these sediments and while forming sedimentary rock, they are from the older pre-existing rocks. So, sedimentary rocks are also known as secondary rocks. Now, these sediments, they are deposited in a basin as a layers with the oldest layer. That is, the oldest layer is at the bottom and the younger layers, they lie over the older layers. So, there are individual layers in sedimentary rock and this individual layer we call as bed. And these beds can be of various thicknesses, both vertically and laterally. So, here you see each bed, they are separated from the adjacent bed by developing a surface of contact which gives rise to a plan. This is called bedding plan, and this bedding plan, they can be horizontal as well as inclined. In this photograph, you can see laminations, you can see bedding plan, you can see the horizontal beds as well as the inclined beds of sedimentary rocks. So, to quote some examples of sediments, sediments can be sand, they can be gravel, mud, then pieces of cells. These are the examples of sediments. And these sedimentary rocks, they are made up of the accumulation of these particles, that is the sediments like sand, gravel, mud pieces, as I have told. These are the accumulation of these particles of older rocks. This can be either as clast, that is a large piece of rock, or as mineral grains, or chemically or biogenically they are precipitated. So, a famous geologist, Francis J. Petrology, he defined the sedimentary deposit as the body of solid material accumulated at or near the surface of the earth under prevalent normal temperatures and pressures, which normally characterize its environment of deposition. So, there are different kinds of sedimentary particles. The particles that form a sedimentary rocks are called sediment, that I have already discussed, and they may be, these sediments, they may be composed of detritus, minerals or biological detritus or organic matter. So, these particles, they are grouped into three groups like terrigenous particles, chemical precipitates and organic materials. Let us discuss them one by one. These terrigenous particles, they are the fragments of the pre-existing rocks that have been worn down into small pieces like gravel, sand, silt or clay by weathering, by mass wasting, even by geological agencies like wind, water or ice and volcanoes. So, here you can see photographs of mechanically transported detrital sediments. These are by the running water, where you can see pebbles, they have traveled a distance and these are mechanically transported. And you see for terrigenous particles, they form basic components of clastic rocks. Examples of clastic rocks like sandstone and shale. And these terrigenous sediments particles can also be comprise volcanic derived clast, clast like as lapilli, bombs or blocks. So, volcanic clastic sediments, they are those composed mainly of grains and clast. They derive from contemporaneous volcanic activity. So, coming to the next group, that is the chemical precipitates. They are transported in solutions as dissolved load, and later they grow as solids in the depositional basin as a result of the chemical precipitations. We can take example of carbonate rocks and evaporates. These are the examples of chemical precipitates. In this photograph, you can see limestone where they are chemically precipitate. Coming to the next group, that is organic materials, they are nothing but the plants and skeletal remains or imprints of organisms. For example, you see the coal deposits and coquina or biological secretions like fossiliferous limestones, they are the organic materials. So, now let us discuss about the types of sedimentary rocks. Sedimentary rocks can be of two types, the clastic rocks and the non-clastic rocks. Let us discuss them one by one. So, clastic rocks, they are the sediments, they are derived from disintegration of pre-existing rocks, and the grain size of these clastic rocks, they may vary from clay, silt, and even sand up to pebble, cobble and boulder size materials. And these clastic rocks, they are transported by gravity, by running water, wind and glaciers, and are laid down in various depositional basins like marine, like fluvial, aeolian, lacustrine, and under prevailing temperature and pressure. If we take example of clastic rocks, they are conglomerate, they are sandstone cells, these are the clastic rocks. Now to the next type of sedimentary rock, they are the non-clastic rocks. So non-clastic rocks, they are the fragments of interlocking minerals formed by chemical processes like evaporation, precipitation, crystallization or biochemical processes, that is accumulation of remains of hard parts of organisms. And these non-clastic rocks, they are subdivided into two types. They are chemical sedimentary rocks, and the second type is biochemical or organic sedimentary rocks. So, let us see what is chemical sedimentary rocks. Chemical sedimentary rocks, they are dissolved mineral products. They are removed from the site of weathering and they are transported in solution and deposited in a basin by chemical precipitations. And the examples of chemical sedimentary rocks, they are the limestone and dolomite. We can take other examples of evaporates like gypsum and rock salt. And the next type of non-clastic rock is biochemical or organic sedimentary rock. So, they are the carbonaceous materials like plant and skeletal remains of organisms form the major component of organic and biogenic sedimentary rocks. So, here is an example of coal deposit. You see, for biogenic sedimentary rocks, these rocks are formed by the accumulation of plant debris in swamps or bogs, and they are the coal deposits. Here you can see a photograph of open cast mining. There is another example, as I have already mentioned. These are the rock deposited by the accumulation of macro and microorganisms, and these are the coquina and sock deposits. Here you can see coquina, they are the shelly limestone comprising of broken shell debris. Now let us take some Common examples of sedimentary rocks. You see shale, sandstone, conglomerate, limestone and dolomite. They are the examples of sedimentary rock, and these constitute about 95% of total sedimentary rocks. And here in this picture you can see conglomerate. These are the field photographs, and in the other picture you can see the breccia with angular clast. You see conglomerate, they contain about of large clast that is more than 2 mm, like pebbles, cobbles and boulders. And the breccia is also like a conglomerate, and they are the majority fragments. They are angular with sharp edges. And in this photograph you can see limestone, and in the other photograph you can see dolomite. And you see limestone, this is a sedimentary rock that contains 50% or more of carbonate minerals, of which at least 50% is a calcium carbonate. So, limestone, this is the most abundant chemical sedimentary rock, and it has variable shades of colors, but the common color is grey, and it is composed chiefly of mineral calcite. So, in this photograph you can see the limestone color is grey, and this photograph, this is showing elephant skin weathering. And in this photograph, this is dolomite, thickly bedded dolomite. When the calcite is recrystallized to a new mineral, this is known as dolomite, and the process of forming of dolomite from lime mud, that is calcite, this is known as dolomitization. And the term dolomite or dolostone is used for rocks in which grains of dolomite dominate over calcite. Here in this photograph, you see this is a ferruginous deposit, and mostly of iron carbonate deposits, and the most common form are the banded iron formation and ironstone. So, ironstone, this is formed when iron and oxygen, they combine in solution and they deposit as chemical sedimentary rocks. So, in this photograph you can see banded hematite ironstone. So, hematite, this is the most common sedimentary iron ore mineral. And in this photograph you can see the phosphatic deposits. They are composed of phosphate mineral. This is phosphorite or phosphate rock or rock phosphate, and they contain high amount of phosphate mineral. So, here in this photograph you can see phosphatic rocks with nodules. So, another common sedimentary rock is the fossiliferous limestone, and this contain abundant fossils like cells and skeletons of organisms. Here in this photograph you can see the fossiliferous limestone. This is from Jaisalmer, and they contain mollusks, corals, etc. And the limestone can form either by inorganic chemical means or as a result of biochemical processes like stromatolitic limestone. In this photograph you can see a stromatolitic structure in limestone, and they are formed from the deposition of microorganisms of cyanobacteria or blue-green algae. Now, let us talk about the sedimentary processes. You see the sedimentary processes here, the rocks existing on the earth at any given point of time, they are exposed to the action of atmospheric agencies like wind, water, air, ice, and resulting in breakdown of these rocks into small particles. They are transported to varying distances, and finally they are deposited in a suitable basins. And in this process there are 4 processes like weathering, erosion, transportation and deposition. Here in this block diagram you can see sedimentary processes. First, you see weathering. This refers to the entire physical, chemical and biological processes that break up and they decay rocks into fragments, and they are dissolved into substances of various sizes. And the next is the erosion. This refers to the combination of processes that separates the rocks or the regoliths, such as the abrasion and plucking. They are caused by moving air, wind, ice, water. And the next process is transportation. Transportation can occur by gravity, by the action of wind, water or ice, and they can carry sediments. And the ability of a medium to carry sediment, that depends on its viscosity and velocity. And the next process is deposition. You see, deposition is the process by which the sediments, they settle out of the transporting medium, and due to the decrease in velocity, or maybe by the precipitate from a solution due to the saturation or change in temperature or pressure, and the medium they are no longer able to carry the sediments further. So, this is the deposition process. After deposition, you see lithification and diagenesis. They are the transformation of the loose sediments that form into solid rock. And diagenesis, this is the process that occurs after deposition but prior to lithification. So, there are these are the processes that involve in sedimentary process like weathering, erosion, transportation, deposition and lithification. So, let us discuss about the depositional environment. The depositional environment or sedimentary environment, this is the space generated or developed on interaction of lithosphere, hydrosphere and atmosphere. And this depositional environment, this is a specific type of environment where you see sediments, they ultimately accumulate after transportation. And these sediments, they are deposited in different depositional environment, and they have distinctive characteristics, and they provide useful information for reconstructing the Earth's history and for understanding the Earth processes. And there are different types of depositional environment. Like you see the fluviatile environment, where it involves the river channels, the flood plains. And if we take example of fluviatile environment, the most famous Indo-Gangetic alluvial deposits, they are the product of fluviatile environment. Another environment is the aeolian environment. Here the arid type of climate is involved, and for example the desert sand dunes of Thar, this is an example of aeolian environment. Another environment type is the lacustrine environment, where it involves inland bodies of fresh or saline water. If we take an example, the Sambar Lake deposits, this is an example of lacustrine environment. Another environment is glacial environment, where the moving masses of ice involved in glacial activity. An example if I take is Gangotri glacier. This is a product of glacial environment. Another environment is the marine environment. This may range from shallow water to deep water. One of the example is the Bengal fan that is in Bay of Bengal, and even the beaches we see in Goa, we see in Puri. These are the examples of marine environment. Here this is a photograph of the flood plains where the sediments, they are deposited in fluviatile environment. This is an example of Son river. Now you see learners, we also have some videos developed by the course team member of Petrology, where you can watch these videos for sedimentary rocks. Here, these are the list. You see geology around us. This is developed in two parts, part 1 and 2. We have also videos related to the structures of clastic and non-clastic rocks. And even you can watch these videos related to weathering and soil products of weathering, which you will get further information about more sedimentary rocks. Learners, let us summarize what I have discussed in this session. I have discussed about the processes of formation of sedimentary rocks, which is ever prevailing phenomenon which involves weathering, erosion, transportation and deposition. And the sediments, they are deposited in a basin as layers with the oldest layer at the bottom and the younger layers lying on over the older layers. I have discussed about clastic rocks. Some examples of clastic rocks are conglomerate, sandstone and shale. And these clastic rocks, they are made up of fragments of rocks or mineral grains that have been broken from pre-existing rocks. I have discussed about non-clastic rocks. Example of non-clastic rocks are limestone and dolomite, and they form from the precipitation of minerals from ocean water or from the breakdown of the cells and bones of sea animals. And I have discussed about the sedimentary environments. The sedimentary environments can be fluviatile, aeolian, lacustrine, glacial and marine. So, I end my session here. Thank you learners listening to me.